Alright, now that you've imported your data into Blender, it is time to clean up your mesh. So what we're going to do is clean up your geometry that you just imported. So one of the goals of this part of the course is to provide you with some basic mesh editing tools within Blender. So where we are in the pipeline right now is in the scene pipeline, editing your geometry to represent your data for the final render. So, what is mesh object geometry? A mesh object geometry is a 3D shape that is represented by vertices, edges and faces. And in this case, it is this cube. As you can see, the green dots are the vertices, and connecting these green dots are the edges, the red lines, and the space in between that is connected by the edges and vertices are the faces. And the type of face is depending on the number of vertices that is representing the face. For example, 3 vertices is called a triangle, 4 vertices are quads, and more vertices than 4 are usually called n-gons, which you usually want to avoid, but it's hard to avoid these kind of quirky meshes when you're importing your data from another 3D visualization program. So why do we do this? Why do we want to edit our 3D geometry? Well, in our case, when we import the data from a 3D visualization program, usually you get a lot of artifacts and you want to remove these artifacts, or sometimes a piece of data which is not interesting is occluding something else which you want to give insight to. So in this example, we have a skull, which is a skull extracted from an MRI scan of a mummy. And here you already see some artifacts from the extraction of the skull, of the isosurface of the skull. Here you see some blobs which are not of any value. In the eyeball you see some residue which could be the eyeball, which is also extracted in the isosurface extraction. And in this case, in this example, I added a brain inside, and if you want to see the brain, you also need to cut away part of the skull. And if you see on the right, this is exactly what I did. I clean up the blobs, clean up the eyeballs, use a Boolean modifier to clip away a part of the skull to look inside. So yeah, clean insides. That is the main reason why you want to do simple mesh editing, but other reasons are, for example, reducing the number of triangles to increase your performance when you're interacting with your geometry or when you're rendering your final images. When you, for example, import your extracted meshes into Blender and your input data was large to begin with, usually these meshes also tend to be very big with a lot of triangles, and then you need to reduce the number of triangles to have a proper interaction with your data. Another reason is to reduce mesh noise that will be coming from your own simulation or the mesh extraction algorithms that you're using. And with the right modifiers, you can smooth out these artifacts, these noise patterns. Another was, of course, the removing of unwanted geometry, which I showed you before. And another reason is to separate the geometry in different parts so that you can make one part a different material, for example, metal, and another part another material, for example, bone. But we're not going to cover this in the basics course, and this will be left for the advanced course. So now that we know the why, we're going to go into the how we're going to do simple mesh editing. In Blender, you have 2 ways to do mesh editing: the non-destructive way and the destructive way. And in this basic course, we're going to only cover the non-destructive way with the use of modifiers. And then in the advanced course, we're going to do the destructive way with the edit mode. So what we're going to cover in the basic course is the use of the subdivision modifier. For example, when your data is actually too little, there's too little geometry, you can introduce extra geometry with the subdivision modifier, so you have more geometry to work with, to smooth out and to visualize. So that's the opposite of having too much geometry. When you have too much geometry, you want to reduce the number of triangles, and that we're going to do with the decimate modifier. And then of course, when you have introduced some artifacts with the extraction algorithm or your simulation, you can use the smooth modifier to smooth those noise out, those artifacts out. And then finally, with the Boolean modifier, we're going to clip, slice, and join meshes so that you can look inside your mesh, or you can join meshes together and have a good insight into your data. So now that you know the theoretical why and how of simple mesh editing in Blender, we're going to do some more practical stuff. I'm going to go through all the simple mesh editing tools of Blender with the mesh editing walkthrough file. So what you can do is either follow along or just watch the video and try it yourself later. So when we open up Blender, we are greeted with the same skull you saw in the first slide. This is the raw extracted ISO surface of the MRI of the mummy. So what you see is what you get from the visualization program. And as you can see right now, it still has the blobs in the eye and around the neck, and it still has the ISO surface extraction artifacts, these circular patterns, which could be removed and cleaned up. But first off, we're going to see what this mesh is made of. And as you can see, it's built up of thousands and thousands of triangles. If you zoom in, you can see every individual triangle is built out of edges, and on the junction points there are the vertices, which are not represented right now, so you cannot see them right now. So actually this mesh is good as it is right now with the amount of triangles. For me, it runs and performs quite well, so I don't need to reduce the number of triangles. If we go back to solid view, I'm going to show you how to use the different modifiers, but then on simpler geometry to get a better understanding on how it works. So for this, we're going to go to the second collection by pressing the 2 button. And as you can see, you see a simple cube. And on this simple cube, we're going to perform the subdivision modifier and then afterwards the decimation modifier, and show you the different options that these modifiers have. So if you want to add a subdivision modifier, we first have to select a cube, which is for me already the case. And then we have to open the modifier properties in the properties panel. And as you can see, there is no modifier present right now. But if we want to add the subdivision modifier, we have to click add modifier. And in the generate column, there is a subdivision surface modifier. So as you can see right now, when we add the subdivision modifier, it actually turns the cube into a sphere. This is not what we want, but this is the case because we, by default, use the Clark algorithm for subdivision, which smooths out all the vertex position when it's adding new faces. And the top face, for example, in this case, was subdivided in 4 new quads, new faces, and then it interpolated vertex position so that it smooths out the geometry. This is not what we want with the cube. We want to retain the shape of the cube. So what we're going to do is use the simple algorithm. And as you can see, it retains the shape of the cube. But now we cannot see the subdivision anymore. So what we're going to do right now is do the same as we did before. Use the wireframe shading. And as you can see, there is still no extra geometry shown. But this is because Blender is smart and wants to optimize the performance of your viewport, and that we can turn off by turning off this option optimal display. If you click that, you can see it adds a new quad, 4 new quads for every quad at every level of the subdivision. So that's basically what the subdivision modifier does. It adds extra geometry and it smooths out with the Clark. So now that we added the subdivision modifier, we can actually remove these quads again with the decimate modifier. And to add the decimate modifier, we're gonna do the same as before. We're gonna go to generate and then select the decimate modifier. This will be placed after the subdivision modifier. So on the original cube, subdivision modifier is added, and then afterwards the decimate modifier is added. Of course, this is quite useless, but for this presentation it's very useful to explain. So now that we added this decimation modifier, we can reduce the number of triangles in 3 different ways. We can collapse, we can unsubdivide, and we can use the planar algorithm. The collapse progressively collapses edges, so it merges 2 vertices together and then reduces the vertex count and triangle count. And for this you can change the ratio, and if you change the ratio slowly, you can see that every single time a new edge is collapsed, and if you go far enough, it will keep the shape until a certain moment, and eventually it will reduce the cube into a different shape. So you don't want to go too far with this one. But for example, now it's still the same cube, but with way less triangles. So that's what the collapse algorithm does. And with the unsubdivide algorithm, well, basically it's just the opposite of the subdivision modifier. For the iterations, it just removes 1 quad out of the cube. And then we have the planar, which merges 2 faces together if it's below a certain angle limit. And in this case, in this cube case, if you select the angle limit of 5, it will just remove all the extra faces you had on the main faces of the cube. But if you do this on a geometry that you extracted from a visualization program, it will introduce a lot of weird geometry. It will introduce a lot of n-gons, and this can give shading artifacts in your final render. So that was it about the subdivision and decimate modifiers. And as I already explained, the Catmull-Clark subdivision modifier already smoothed out the geometry itself. But there are also dedicated smoothing modifiers. And what we're going to do right now is press the 3 button on your keyboard. And then you see 3 individual meshes. And if we do solid, you can see they are having different types of noise. This is a very strong random noise. This is more of a smooth kind of noise. And this is more like a specular noise. And there we're gonna apply some smooth modifiers on so that we can remove the noise itself. First off, we're gonna select the spiky ball, and we're gonna add a modifier and then go to the deform column and just select the smooth modifier. And as you saw, it already shrinked a little bit, but if we repeat this modifier multiple times, it will slowly but surely smooth out the rough edges while trying to retain the shape. And then you can also change the factor, but as you can see, this smoothing factor can also generate artifacts if you're not careful enough. So you have to watch out with this smoothing algorithm. But yeah, as you can see, 1 with multiple repetitions already is enough to smooth out the rough edges of this geometry. And next in line we have Suzanne, the monkey icon of Blender. And I've placed a displacement modifier on this object, which displaces every single vertex based on a texture underneath, and I used for that a noise texture. So basically I generated a noise on the monkey head. And what we're gonna do is remove this noise with a smooth modifier. And as you can see, the smooth modifier is already added, but the only thing you have to do is enable it for the viewport. And that's by pressing this button. And if you press it, you see that it looks like it's perfectly removing all the noise. It does perfectly remove all the noise, but it also reduces the volume of the object. As you can see, if you individually change it and remove also the displacement and then add the modifier, the smooth modifier, you can see it shrinks the volume and it loses detail around the eyes. And sometimes you don't want that. Sometimes you want to keep these details in the 3D object. So for that we have a remedy. We can use also a different modifier. It's called a Laplacian smooth modifier. If you remove this modifier, we just clicked on the X and then go to deform, smooth Laplacian modifier, and then increase the lambda factor. Watch out with this this modifier is quite intense in calculations, so don't just swipe the repeat button all the way to the right, because then your laptop or PC will have a hard time calculating it. But in this case, you can see it does smooth out the noise, for example on the flat areas, but around the eyes it preserves the detail, also the detail generated by the noise. So in this case it's not really what you want, but it does preserve the volume. If you disable and enable the Laplacian smooth modifier, you can see that it doesn't remove the detail. But yeah, this modifier is better for just removing heterogeneous noise. So one way to show this is to use an object, a normal cube, with some heterogeneous noise. And I already placed all the modifiers, so you only have to enable it by pressing this display enable button. And it takes a little while to calculate because it has 20 repeats. You can also reduce the number of repeats and increase the lambda. Oh, that's a bit too much. As you can see, it's quite hard to navigate with these intense algorithms, but as you can see, it kind of removes the noise and preserves the shape of the cube. Although it rounds the edges a little bit. So yeah, it's just you have to find your way through the smooth modifiers and see which one keeps the most detail and removes the most noise for you. And that's it about the smooth modifiers. And we're now going to go to collection 4 by pressing the 4 button on your keyboard. And then you are greeted with the skull again, but also a wireframe sphere. And we're going to perform a Boolean operation on the skull with this sphere. So if you select the skull, you can see already a Boolean modifier is added. If you want to add it yourself, you can press the add modifier button and you see it here, the Boolean modifier underneath the generate column. And on this Boolean modifier, we are using the difference algorithm to remove the difference between the skull and the sphere. And as you can see here, the clipping sphere is selected as the object to use to clip away the skull. So if we now move this sphere towards the skull, you can see it removes part of the skull where the sphere is in. So this way you have a nice clipped skull and you can see the inside of the skull. Just gonna drag it around to the other side because that's where the light is coming from in the shaded version. And if you now put the shading on rendered, remove the layout, you can see you can perfectly look inside the skull with the Boolean clipping. And that's everything about the non-destructive basic course modifiers. So now you can begin with your own exercises.